Hi and Assalamualaikum. We are from A4CS1435C, Group 8, and we will be presenting our queuing theory project for subject QMT342. For this project, our observation is the queuing system at Family Mart. But before we start, let me introduce our group members for this project. We have 3 members and they are Muhammad Farid bin Rizwan, Muhammad Alif Muzamil bin Mat Isa, and Syed Muhammad Hafi bin Syed Ahmad Tarmizi.
For the introduction, our project is located at Family Mart Nadi Putrajaya. The address is number 58, Jalan Diplomatik, Berizin 15, 62000 Putrajaya, Wilayah Persekutuan Putrajaya. The operating time for Family Mart Nadi Putra starts at 7 am to 12 am every day. The number of server is only 1. This is the photos of service center building at Family Mart Nadi Putrajaya. This is the example of customer service and waiting line at Family Mart.
Moving on to the characteristics of the queuing system. 2.1 Arrivals characteristic. For the first one is the size of the calling population, which is infinite or unlimited. It means that the arrival rate is not affected by the number of customers in the system. The next one is the pattern of arrivals at the system. The assumption for arrival at the Family Mart follows the Poisson distribution, where the lambda here is equal to 24 customers per hour. And the last one is the behavior of the arrival, which is patient customers, which means that the customers are waiting in the queue patiently until they are served. 2.2 Waiting line characteristics. For the first one is the length of the line, which is infinite or unlimited. It means that there is no restriction on the number of people who are waiting in the line or in the queue. And the second one is the queue discipline. The Family Mart applies the concept of first in first out, FIFO, or sometimes it is called as first come first serve. 2.3 Service facility characteristics. For the first one is the configuration of the service system. For the number of channel, it is a single channel system, which means that there is only one counter is open or there is only one server. For the number of faces, it is a single face system, which means that the customers are served only at one station. The second one is the pattern of the system. The assumption for service times follows the exponential distribution, where the mu is equal to 30 customers per hour. 2.4 Basic queuing system configuration. For the Family Mart, the basic queuing system configuration is single channel, single phase. To elaborate, the customer will arrive and make purchases, then they wait in the queue to make the payment, and then they will leave the Family Mart.
Last part for this project is result and conclusion. For the result, we obtain 0.17 per hour, which is 10.2 minutes for the average time a customer spends in the system by using the formula 1 over mu minus lambda, where mu is 30 and lambda is 24. Next, for the average time a customer spends waiting in the queue is 0.13 per hour or 8 minutes. We get this answer by using the formula mu minus lambda times mu and divided by lambda. For the last one, utilization factor, using the formula lambda divides mu, we obtain 0.8. Lastly, conclusion. For question 1, we are able to answer yes, since mu greater than lambda, where the customers are served at a faster rate than they arrive. For the second question, we likely to say yes, because they are being served on time. In a nutshell, what we have learned from the project is, if the average service rate is greater than average arrival rate, it shows that the customers are served at a faster rate than they arrive. Meanwhile, if the average arrival rate is greater than average service rate, then the queue will get larger and waiting time will be longer. Hence, the service will become slow.